Hey guys, we are back here with our coach book once again, and we are on page 78, and we are looking at global weather patterns. So if you want to follow along, we are on page 78, and I'm going to start reading here. Weather forecasters look at local weather conditions. They also need to understand bigger weather patterns that move over great distance around Earth. The air mass moving into your town right now might have come from near the North Pole. The ocean water flowing past your state right now may have come from near the equator. The air masses and the water affect your weather. So look at global wind patterns here. Global weather patterns affect local weather patterns. Currents in the atmosphere and ocean transfer heat around the world and cause weather patterns. A current is a flow of air of water for a certain direction. In the air, these currents are called global winds. Recall from lesson 8 that energy is transferred from the sun to the earth as radiation. As the sun's energy reaches Earth's land and water, they take in much of that energy and are heated. But Earth is not heated evenly. Okay, so let's look at the first question. Global weather patterns affect blank weather patterns. Global weather patterns affect, very first line there, affect what kind of patterns? Local, so that's your very first one. The transfer of heat through convection currents in the atmosphere causes weather blank. So we have not gotten to convection. I have not seen the word convection here, so we'll keep reading, and if we don't see it, then we'll come back and look at it, okay? The sun's light strikes Earth more directly over the equator at the poles. The parts of the Earth are closer to the poles get less direct sunlight, so the different parts of the Earth have different temperatures. As you learn in the last lesson, temperatures near the equator are much warmer than those near the poles. Air is heated by conduction. When air moves in contact with Earth's surfaces, heat is transferred by air. So the uneven heating of the Earth's surface means that air is heated unevenly too. The uneven heating causes air movement or wind. When air is heated, the particles move farther apart. When the air becomes lighter, so it rises, then cooler, heavier air moves in under the warm air. As the warm air at the equator rises, large areas of low pressure form there. At the poles, the air is cold, so it sinks. Areas of high pressure form. Over short distances, wind blows from areas of high pressure towards areas of low pressure. You might expect global winds to move straight down from the poles toward the equator, from the high pressure areas to the low pressure areas. But the paths of global winds curve because Earth spins on its axis. This diagram below shows the curving of global winds. In the northern hemisphere, winds traveling from the north curve to the east curve, winds traveling from the south curve to the west curve. Weather forecast uses information to predict how air masses will move. So as I was looking, I took a moment and I looked at this and I said the transfer of heat through convection. I think this is supposed to be conduction because that's over on the other side there. Currents in the atmosphere and ocean causes weather. I'm going to give you the answer here because it's not fully stated in the thing. It's going to be patterns. And because it's not stated, that's why I'm giving you the answer. In the air, these currents are called. So when we are having weather things, we are going to be having what kind of winds? We have global. Okay, guys. So these currents are called blank winds. What are these? These are called global winds. Energy from the sun is transferred by radiation of Earth's land and water, causing blank heating. So we're talking about Earth, the sun radiating, and it's going to Energy for the sun is transferred by radiation to Earth's land and water, causing blank heating. Okay, guys, the answer to this one, it says energy from the sun is transferred by radiation to the Earth's land and water, causing blank heating. Think about what kind of heating. It's very... Oh, I'm sorry, you can't see. No wonder. I'm like, I should have looked up. The heating is what? Right there. Uneven. Places near the equator receive more of the sun's energy than places near the... So places near the equator receive more than those near the what? Our what? Our poles, right? Or your northern hemisphere, or whatever you want to write there. Making temperatures warmer near the blank and colder near the poles. Where is our warm area? Near the equator and colder near the poles. The uneven heating causes air movement or blank. So the uneven heating causes blank, or the uneven hair causes air movement or blank. So when we look at this, we're looking at how it is traveling. We're going to come back to that. I feel like we're going to have to revamp that question again. This whole one is kind of a little bit differently, and I kind of got to search a little bit more for the answers. So let's read the jet streams, and then we'll look again. A jet stream is an air current of the upper atmosphere that flows from the west to the east. There are jet streams flows over North America. It greatly affects the weather. Jet streams do not follow regular paths around the earth. Instead, they dip, they bend, they change position. You might think that of them as rivers of air. The diagram below shows the polar wet stream. So, we're talking about jet streams over here. When we're looking at it, we're going to skip the part that says the uneven heating causes air movement or blank. Large areas of low pressure form as warm air rises near the equator, but areas of high pressure form as blank sinks near the poles. So high pressure forms, look up top here. Okay. Over a short distance, the wind blows from areas of high pressure towards areas of low pressure. You might expect global winds to have moved straight down from the poles toward the equator, the high pressure areas into the low pressure areas. But the paths of global winds curve because Earth spins on an axis. The diagram below shows the curving global winds. So therefore, it is able to predict it. Now, when we look at this, it says large areas of low pressure form as warm air rises near the equator, but areas of high pressure form as blank air sinks near the poles. What kind of air is sinking near the poles? What kind of air? What is it? It is going to be what? We're sitting here, look here. As warm air at the equator rises, large area of low pressure form there. At the poles, the air is cold, so it sinks. Areas of high pressure form. So when we're looking at this and it says large areas of low air pressure form, warm air rises the equator, but the areas of high pressure form as cold air sinks near the poles. Over a short distance, wind blows from areas of blank pressure towards areas of lower pressure. So where are we starting? Where does it is coming from? It's coming from pressures of right here. So you're having high pressure to low pressure. The paths of global winds blank because of the Earth spins on an axis. So the paths of global winds, what do? They curve because Earth spins on an axis. A jet stream is a air blank in the upper atmosphere. A jet stream is an air, what is it? Look at the word after air. Current in the upper atmosphere that flows from west to east and does not follow regular patterns around the Earth. Polar jet streams that dip, so we have not gotten to polar jet streams. Okay, so I'm going to turn the page. Well, we do, in a sense. He says, you might think of them as the diagrams below shows the polar jet streams. Okay, so we're going to turn the page and see if we can find out information about the polar jet streams. When the polar jet streams dip south, it lets cold air form. Canada flow down into the United States. When the subtropical jet streams bend north, it lets the warm air flow from the south. Jet streams also affect the paths of storms. Meteorologists watch the jet streams to predict how storms will move. So right here, we're going to look at the jet stream. Polar jet streams that dip blank bring cold air from Canada. So what do? They're going to dip what? Look at the very first thing. They're going to dip, besides down, I like a better word than down, south. They bring cold air from Canada to the United States. Subtropical jet streams that bend north bring blank air from the south. What kind of air is going to be coming from the south? It's going to be what? Warm air from the south. Ocean water moves and flows in blank like air. So we are going to look at our ocean currents. Like air, ocean water is always moving and flowing as currents. And like global winds, ocean currents flow in certain directions. You can think of a current as a stream or a river in an ocean. Currents move along distances in the Earth's ocean. Winds cause currents near the water surface. Other currents flow deep below the surface. The map below shows some of the main ocean currents. The arrows show which way the currents flow. Now think about it. I've talked about this with my class. It's moving in this direction. This is moving in this direction. How do we usually get our hurricanes? They usually come from over here and they come up here because our currents are moving this way. Now, when we get our jet streams and stuff from the west over here, they're moving in the opposite direction and it's pushing it in onto California, which is then going to send it over the mountains and eventually affect us. So they're moving at a counterclockwise way and we are moving at a clockwise way. So they're counter and we are clockwise. Okay. Some currents are warm and some are cool. Warm currents flow away from the equator. Cool currents flow away from the poles. Ocean currents affect weather patterns. Warm currents from tropical areas carry warm water near the coastlines of cooler areas. The warm water helps keep land near the coastlines warm. Cold water currents from the poles travel towards the equator. The cold water brings colder temperatures to some coastlines in those areas. So, ocean water moves and flows in blank like air. What does ocean water move in? It moves in currents like air. These currents always flow in a certain, right there, second line, certain direction. Currents near the water surfaces are created by blank, but other currents flow deep below the surface. Currents near the water surfaces are called currents move along distances of the ocean. Wind causes currents near the water surface. Other currents flow deep below the surface. The map below shows some of the main currents. So it's saying currents near the water surfaces are created by, what are they created by? Winds. But other currents flow deep below the surface. Some currents are blank and some are cool. Down here. Some currents are warm and some are cool. Warm currents from blank areas carry warm water near the coastlines of cool areas, keeping land near the coastlines warm. So warm currents from, where are they coming from? Where are the warm water coming from? The equator. It says the equator areas, or you can put southern areas if you would like. Carry warm near the coastline of the cool areas, keeping land near coastline warm. Cold water currents from the poles travel blank the equator. So cold water currents travel towards the equator, right? Bringing cold temperatures to some coastlines in the areas. The blank is warm ocean current in the Atlantic Ocean. We're going to look at this one over here. So we're going to go to page 81 and talk about the Gulf Stream. The Gulf Stream is a warm ocean current in the Atlantic Ocean. It flows northeast along the eastern coast of the United States. The Gulf Stream moves warm water out across the Atlantic Ocean towards north. The Gulf Stream helps keep weather along the eastern coast mild by warming the air and land during the cooler months. Radiation from the sun warms the waters of the Gulf Stream as well as the other warm currents. Then by conduction, the water warms the air above it. When warm water turns warm over coastal land over air which it moves, the Gulf Stream also affects weather patterns on the opposite side of the Atlantic Ocean. It helps keeps winter gently mild along the western coasts of Europe. Did you know the Gulf Stream affects not just weather, but also the numbers of fish found in parts of the Atlantic Ocean? Many kinds of ocean fish are found in the warmer waters of the Gulf Stream. So some of the best fishing is found off the coast of Florida or in the Carolinas. The change in ocean temperatures can affect weather patterns for long periods of time. Every few years, such a change occurs in the Pacific Ocean, as an unusual warming of a surface water in the eastern Pacific near the equator is known as El Niño. An unusual cooling of the same water is known as La Niña. These changes of water temperature affect the patterns of North and South America for long periods of time. So if we're getting El Niño, it's usually involving warmer water, and then if water rapidly cools, we're going to have a La Niña. So we've talked about La and El, feminine and masculine. These are Spanish words, and we've talked about it a little bit this year. So when I'm looking at, wrong side. When I'm looking at this, it says right here, the blank is warm ocean air in the Atlantic Ocean. What is it? The Gulf Stream? Is warm ocean current in the Atlantic Ocean that flows northeast along the weather along the eastern coast, blank in the colder months. So the Gulf Stream helps the weather along the eastern coast by warming the air and land during the colder winter months. So therefore, it says keeping weather along the eastern coast. What did we just say? Warm during the cooler months. The Gulf Stream also helps keep winters generally mild along the blank of coast of Europe. So it also keeps winter weathers generally mild along the western coast of Europe. So we're going to add western here. The blank ocean experiences an unusual change in temperature every few years is known as La Niña and El Niño. So the blank ocean. What ocean? Where is it going to be found? Last paragraph. The Pacific Ocean experiences an unusual change in temperature every few years known as El Niño or La Niño. El Niño is the blank of surface water in the eastern Pacific Ocean. So El Niño is the what is happening with here? El Nino is warm, right? El Nino is the blank of surface water. Unusual warming of, so this is warming. And La Nina is then the unusual cooling of the same water. These changes of water temperature affect weather patterns in North and South America for long periods of time. Okay, we're going to look at our questions over here. How do global winds and ocean currents transfer heat around the world? By convection, by conduction, by transpiration, by radiation. Okay. In what direction do jet streams usually flow? From east to west, from west to east, from north to south, or from south to north, or from north to south. Jet streams. If you don't know, go back and look at your notes about jet streams and what direction they move. How does the Gulf Stream affect weather patterns? A. It moves air, which causes wind to blow. B. It blocks air, which stops wind from blowing. C. It cools air, which cools land along the coast. Or D. It warms air, which warms land along the coast. So how does the Gulf Stream affect weather patterns? So once again, if you don't know, go back into your notes. And the very last question here. Which provides unusual cool ocean waters that affect the weather patterns in North America? El Nino, La Nina, subtropical jets, or the Gulf Stream? Unusually cool ocean waters.